Hi everyone, today we are learning about negative exponents and multiplying and dividing powers with integer exponents. You do not need to write down everything we cover in this video, but be sure to jot down important information and at least one example of each type of problem that we cover. Also remember that you can pause the video to jot down important notes, rewind the video to view information again, and fast forward if you think you got it already. Just be careful and be sure you don't miss out on anything important. So let's begin. Up until this point, you have only dealt with positive integer exponents. So that means that your powers were positive numbers. We talked about how anything to the fourth power is 1 times that number multiplied by itself 4 times. Anything to the third power is 1 times that number multiplied by itself 3 times. To the second power or squared is 2 times. To the first power is 1 times that number only once, which leaves 1 by itself for the 0 power. So as you are getting higher in your powers, if your powers are getting bigger, you're multiplying that base number, right? If you are getting smaller when you look at the power, so going from 4 to 3, you can think about it as dividing. So 256 would divide by a 4 to get to 64. So let's have that out here. 256, that's 4 to the fourth power, divided by a 4 instead of multiplying will get you 64. So each time you would divide by 4, because you're getting 1 less 4, to get these numbers. Divide by 4 to get to that 4, divide by 4 to get to that 1. So moving upwards for your power, you are multiplying the base number an extra time. Moving downwards for your power, getting smaller, you would divide that base number 1 time. Using this pattern that we've talked about, you can figure out what happens if you have negative exponents. Okay, so right after, if we were going in a downward trend, it goes 4, 3, 2, 1, 0, and then the next power would be negative 1. So we are starting to go into the negative region here. The good news is it follows the same patterns. As you go up, you multiply by the base number again. As you go down, you divide by the base number. So think to yourself and make a prediction. What do you think 4 to the negative second power will be? What kind of answer will it look like? Using that pattern that we just talked about. Go ahead and pause the video and jot down your prediction. If you said that 4 to the negative second power will be a negative number, you are incorrect. However, you are not alone. A lot of people think that the answer will be a negative because there's a negative power. That is not correct though. Remember, we are following that same trend, that same pattern. As we are decreasing in our power, so as we're going from a bigger power to a smaller power, we are dividing. So starting with 256, we divided by 4 to get to 64. 64 divided by 4 was 16. 16 divided by 4 was 4. 4 divided by 4 is 1. And here's where we get to the tricky part. We're going to continue the pattern, but it doesn't make it into a negative number. We're just dividing it by 4 further. So 1 divided by 4 is the same as 0.25 or 25 hundredths. Then to get from 4 to the negative first power to 4 to the negative second power, we would divide by 4 again. So we get 1/16 or 0.0625. It's the same as 1/16 because if you take 1 divided by 16, you get that number, okay? So we don't get a negative answer. We get a fraction or decimal answer. And that's the tricky part here. Basically, as you get to 0 and below, it starts getting tricky, right? For 0, the answer is 1. You would think that it's 0, but it's because of that 1 left over. And then your negative powers, you would think that they are negative answers, but they're not. They're just fractions. They don't actually become negative. Becoming negative would be like if you owe someone money, right? And it's to the left of the number line. A negative power just means you're continuing to divide. So the number is getting smaller and smaller, but it never becomes negative. It's just getting closer and closer and closer to 0. But it never passes to the other side of 0 to become negative. It still stays a positive number. So if you haven't paused the video and jotted down this table, you want to go ahead and do that now before we move on. So go ahead and pause the video, jot down this table. I would also jot down this pattern on the side and maybe put it in a different color so it pops out at me. And then make sure that you write down that a negative exponent never ever results in negative values. I mean, unless the number, the base number itself was negative, right? But this base number has been a positive 4 the whole time. So that means that the value of the number is always going to stay positive. So with a positive base and a negative exponent, it doesn't result in a negative value. That's dependent on the base number. What it does result in is fractions or decimals, just depending how you write it. You can write it as a fraction, or you can divide the numerator by the denominator to get the decimal. This is because they're the result of dividing the base number, or you can think about it as multiplying by the base number's reciprocal. So instead of dividing by 4 each time, you can think about it as multiplying that 4 on the bottom, the denominator now. So instead of times 4 times 4 times 4, you're multiplying 1/4 by 1/4 by 1/4 by 1/4. You might have also realized that there is a pattern. The 0 power is kind of like the barrier. And then once you get 1 above, you get a 4. 1 below is 1/4. 2 above is 16. 2 below is 1/16. 1 above is 64. 3 above is 64. 3 below is 1/64. 4 above is 256. 4 below is 1/256. Some people have compared it to like the upside down in Stranger Things. It's literally the same thing, but everything is flipped. So that's what the negative exponents do. They give you the same power, but it's now going to be in the denominator because you're dividing it instead of multiplying it. So that's negative exponents. Make sure you have that written down before you move on. Now a little note about exponent etiquette. What do we mean by etiquette? We mean like how we do things properly in math. There are certain ways that we write our exponents. We do not like negative exponents. We avoid them, okay? So we try to change them to positive exponents. Now, it's very important that you remember you can't just, change them up because it might change the value. So when you change it to a positive exponent, you do have to toss it to the other side. Because remember that negative exponents are just the positive exponents, but on the opposite side. So if you do want to change it to a positive exponent, you do have to flip it to the other side. Here are some examples. So 1 over a to the negative third, you can change it to a to the positive third power, but then it has to flip to the numerator and just becomes a to the third power, or a cubed. It switched from the denominator and negative to the numerator and positive. 5 to the negative seventh power was on the top and negative. Now it goes to the bottom and it's positive. For the third example, c squared is on the top and it's positive, so we can keep that there on the top. D to the negative fifth power was negative and it was on the bottom, so if we wanted to change it to positive, we gotta change sides, okay? So we have to change signs and sides, okay? So you're not only changing the sign of it, but you're changing which side it's on. If it was on the bottom, it goes on the top. If it was on the top, it goes on the bottom. If you change its sign from negative to positive. You can't just change the sign and move on, because then you've changed the actual value. So we'll do some examples with that. Here is our first example. Here is negative exponents in Khan Academy. Go ahead and pause the video, see if you can do it on your own first. All right, so like we said, we have to, if we're changing the sign, we are going to change the side as well. Right now, y to the negative second power, it's negative and it's on top. It's the numerator, right? It's not on the bottom of a fraction. So what we have to do is we have to change it so that it's positive and it's on the bottom. So it becomes 1 over y to the positive second power. So both have to flip. So our answer is 1 over y squared. You're probably thinking to yourself, whoa, what is this? Y square rooted? We haven't learned about what that power is, right? So for your information, they're there to trick you, but anything square rooted, I think I said squared by accident, but I meant square rooted. Anything square rooted actually has a, oops, let me back this up so I have room to write it. Anything square rooted is the same as the half power. And we haven't talked about that, but that's just a little extra piece of information if you're interested, okay? Okay. So let's try another one. Go ahead and pause your video and see if you can try this one on your own. Okay, this one we have 4 to the negative third power. It's negative and it's on top. So to change it, we need to change it to positive and now flip to the bottom. So now you should get 1 over, so that it's on the bottom, 4 to the positive third power, because now we're changing it to positive. So your answer is C. Ooh, A, it was there to trick you. 1 to the third power, you took away the power from the fourth. That's not good. And then this one here, you changed the base number. We're not changing the base number. This base number is a 4 being multiplied each time. Here, you changed it so that it's a 4 being multiplied each time, but then you're adding a negative on the outside. Remember, negative exponents do not result in negative values. So that was there to trick you. Okay, let's do one last example of negative exponents. Pause your video and try this one on your own. Okay, this one right here is positive and it's on the bottom. So it says select the equivalent expression. Normally we would like this. It's already positive, it's great, okay? But right now they're saying that they want an equivalent expression. So we need to figure out what that means. Okay. We need it to be positive and on the bottom. So it becomes, oh wait, sorry, we need it to be negative and on the top. So it would become 6 to the negative fifth power, okay? So that would be this one right here. It was already positive and on the bottom. They wanted us to find the equivalent expression, which would be negative and on the top. So that would be 6 to the negative fifth power. But like I said before, this is what we want. Answer choice A is the same value, but we don't like writing it like this. Exponent etiquette tells us that we prefer this form of it. But these two are the same. We just like this one better. Okay? So that's the equivalent. There we go. All right, so you're switching both the sign and the side. Let's go on and do some examples with multiplying and dividing powers now with integer exponents. So this is basically the types of problems you've already done with multiplying and dividing powers, but up until now you haven't had to deal with integer exponents. So that's what we are practicing here. Go ahead and pause the video and see if you can solve this one on your own. All right, I see that this is a division problem with the same bases. So I should remember from a previous lesson that when I'm dividing exponents with the same base, what I'm actually doing is I am subtracting the powers. And remember, orders matter. The order does matter. So we're taking the top minus the bottom. Okay? So let's do that. This right here would be the same as, let me use a different color so it pops. This would be the same as a to the negative 13, the top number, minus the bottom number is negative. Okay? So this right here is my negative 13, and then this is the minus, and this is the negative 6. Okay, that's why there's so many of those minus signs there. The negative 13 was already there. That's this one right here. This minus sign is the subtraction. And then this negative 6, it was negative. So that's where that negative comes from. Okay, a lot of times people see the negative on the bottom number and they forget about the actual minus sign. So here we have 3 minus signs. You can check yourself next time. You have started with 2 minus signs, so you should end with 3 so that you have the original 2 and the minus sign. Sometimes people forget. They see all the minus signs and then they just write something like this. Okay, so they just wrote the original 2 numbers. They didn't actually subtract them. So you want to make sure that doesn't happen to you. Okay, so what is this going to equal to? This equals to a to the 13, negative 13. These are 2 minuses next to each other, so they become a plus, a 6. So it becomes a to the negative 13 plus 6. You could use your calculator for that. Negative 13 plus 6. So that's negative 7. Okay? You can either use your calculator for it or you can do it in your head. Negative 7. You could do it in your head by thinking there's 13 negatives. Three, 6, 9, 10, 11, 12, 13, and then there's 6 positives. 1, 2, 3, 4, 5, and 6. Each negative and positive will cancel each other out. So here's a pair, they cancel. 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 Pair, pair, and that's it. So I'm left with 1, 2, 3, 4, 5, 6, 7. 7 negatives, okay? So if there's more of the negatives, there's 13 negatives, you know your sign is going to end up with negative because you have canceled out all the positives. So you're basically subtracting them. 13 minus 6 is 7, and you know the sign left over is going to be the one with the most on their side. So it's negative 7 left over. Or you can use calculator. So here, we have it written as a to the negative 7th power. They said that they want the expression in the form of a to the nth power. So we could keep it like this, is what they're saying. A to the negative 7th power. Okay? Let's try another one. So here we have 6 to the negative 6th power divided by 6 to the negative 5th power. Go ahead and pause the video, see if you can solve it on your own. Okay, in this problem, we have division, so that means we're going to subtract. So this becomes 6 to the negative 6th minus that negative 5. So we have the negative 6 minus the negative 5. I want to make sure all my minuses are there. So this is the same as 6 to the negative 6 plus, because I have two negatives that cancel each other out, 5. So it becomes 6 to the negative first power. How did I know? Because I have 6 negatives and I have 5 positives. Each pair of negative and positive is going to cancel each other out. So I end up with 1 negative. Okay, so my answer is 6 to the negative first power. 6 to the negative first power. And that should be my answer. Okay. So what does 6 to the negative first power actually mean? It means 1 over 6 to the first power, which is the same as 1/6. Not a negative answer. Let me know if you have any questions as you work on these. If not, I will see you in class, and good luck on these.